unconscious mental life. This happened to me once about 2 years ago, and the only way I was able to fix it was by rebooting, which I'm not going to do now. The Freudian theory of dreams lasted as the dominant theory of dreams from about 1900, when Freud originally published it, well into the latter part of the 20th century, when it was gradually replaced by a more physiologically, more neuroscientifically oriented theory of dreams, originally proposed by two Harvard researchers, Alan Hobson and Robert McCarley, as what's known as the activation synthesis theory of dreams. And what the essence of the activation synthesis theory of dreams was that during the night, as the individual cycled between periods of rapid eye movement sleep and slow wave sleep in the 90-minute cycle that we're familiar with, that during rapid eye movement sleep, the cortex, cerebral cortex, became very alive, very activated, and basically, as a result of this activation, people experienced various kinds of dreams. Now, a couple of things that are important here. The first is that this activation occurred in a cyclic fashion about every 90 minutes. Okay, so there's the first departure from the Freudian dream theory, where Freud thought that dreams were instigated by repressed desires and repressed affects, and if you had those, they came out in dreams. If you didn't, they didn't come out in dreams. Whereas Hobson and McCarley argued that there was really no psychological instigation to the dream, that everything just happened on this natural 90-minute cycle. But this activation, cyclic activation of the cortex, had certain kinds of consequences for the person's conscious mental life, which was, first, the eye movements begin to occur, and there's feedback from the muscle systems that control the eye movements, and that gives rise to the experience of looking at things. Okay. Then there is activation of the occipital cortex and various kinds of visual images. There are motor commands, so that there's a sense of walking or whatever. There is vestibular activity, activation that gives the person the experience of moving. And then there is activation of the autonomic nervous system, giving rise to increased levels of emotionality. And so that's the activation part. There's massive cortical activation that occurs during periods of REM. And then the synthesis part is that these activations of various mental structures are basically random, haphazard, and meaningless. And what happens is that the activated cortical structures then try to take these little bits and pieces of images or whatever and synthesize them into the best story that you can tell. So you've got, there's dragons, and there's bicycles, and there's the Eiffel Tower or whatever, and then all of a sudden you've got dragons riding bicycles down the streets of Paris, because it's the best story you can make out of these things. The upshot of this, however, is that dreams are essentially meaningless. That's the other major difference between the activation synthesis idea and Freud's idea, which is that Freud thinks that dreams have meaning. They represent repressed or unconscious wishes or desires that are being fulfilled in the dream life. But Hobson and McCarley argued that now it's just a matter of random activation of various kinds of neural structures, leading to corresponding kinds of sensory activity, and there's just no more meaning to it than that. When I dream about dragons riding bicycles through the streets of Paris, it doesn't mean anything at all. Okay, that's the general idea. So what we have here is a turn from a psychological theory of dreaming to a neuroscientific or a physiological theory of dreaming, in which the psychology really plays very little part at all. Hobson and McCarley's theory was stimulated by the discovery of what are known as PGO waves, discovery initially made in research on cats by a French physician, Pierre Jouvet. And what he discovered was that right before each REM cycle, remember cats and rats also have REM cycles. We don't know what they do during them, but they have REM cycles. But right before the REM cycles, recording using microelectrodes placed in various parts of the brain, they saw a characteristic burst of activity that began in the pons and then led to activation in the lateral geniculate nucleus, which, as you'll remember from Psych 1, connects, is part of the visual system, and then this activation pattern passes to the occipital cortex. They're called PGO waves because they start out in a particular place, and there's like a wave of activity. You can see activity arising in the pons, and then a little bit later you see activity arising in the lateral geniculate, and then a little bit later still you see activity arising in the occipital cortex. And the general idea here is that it's these PGO waves that produce both rapid eye movements and whatever it is that is the corresponding experience of dreaming. The Hobson and McCarley activation synthesis theory of dreams quickly became the chief rival to the Freudian theory of dreams. And Hobson has battled it out with various kinds of Freudians really ever since, using a slight modification of the activation synthesis model known as the AIM model of consciousness. AIM stands for activation, input source, and modulation, AIM, A-I-M. And Hobson has proposed this AIM model as what he calls an integrative theory of mind-brain states. That is, Hobson argues that his AIM model can take account on neurophysiological grounds of all the different states of consciousness that people experience, though he's only really worked this out in detail for sleep and waking and dreaming. Okay, so here are the elements of the AIM model, which tries to connect two different levels of analysis: the psychological level of experience and the physiological level of what's actually going on in the brain. One of the interesting things about the Hobson theory is that he really tries, in a way that many people don't, to explore the links between mind and body and mind and brain. And in fact, it's a characteristic of Hobson's writing that he uses the term mind-brain, okay, mind-brain, which you don't always see in writings about consciousness, basically because Hobson argues that mind and brain are the same thing, okay? But that the activities of the mind-brain can be analyzed at two different levels of analysis. At the physiological level, we have cortical activation that basically arises from the reticular activating, the reticular formation and the pons from these brainstem structures, and then activates the cerebral cortex, and that produces, at the psychological level, a state of alertness of various kinds. Then we have what he calls sensory motor channels. You'll remember that in REM sleep, there is a gateway in the pons that's closed that prevents the sleeper from getting much sensory input, and also prevents the sleeper or the dreamer from engaging in much kind of motor output. So we have, corresponding to these sensory motor channels, what he calls the input source, whether the inputs to the cortex are derived from sensations and perceptions of the external world, or more internal memory-based kinds of things. And then finally, what he calls neuromodulatory balance. He argues that there are shifts during the night, or on other occasions as well, in the dominance of two neuromodulatory systems, either one that's based on so-called aminergic neurons, which use norepinephrine or serotonin as their constituents, or cholinergic neurons, which use acetylcholine. And the balance between these aminergic and cholinergic neuronal systems then creates a person's level of attentiveness. Notice that there's a difference here between alertness and attentiveness, which is reminiscent of that earlier distinction between wakefulness and awareness that we talked about before. Okay, so again, here are these structures in the brainstem that are important for these various kinds of that generate these neuromodulatory systems. And just to go through them very quickly, because it's not the heart of what I want to talk about here. Here we've got the noradrenergic neuromodulatory system, where neural activity arises from the locus coeruleus and then passes on to various parts of the spinal cord and up into the neocortex. Here's the serotonergic neuromodulatory system. Again, you've got these structures, the dorsal raphe, generating activity that again goes to the brainstem and the cerebellum and the limbic system and the neocortex. Acetylcholine doing much the same thing, but arising from different structures. These cholinergic nuclei in the brainstem and also basal forebrain nuclei, and again passing up into the limbic system and the basal forebrain. Technically, in Hobson's theory, there's a fourth neuromodulatory system, what he calls the dopaminergic neuromodulatory system, which he thinks plays a role in various kinds of drug states, especially those that are produced by LSD, but is not important for sleep and dreams, so we're not going to do anything about it at the moment, except just be sad about this. Okay, so AIM, activation, input source, and neuromodulatory activity, M, that gives us three different dimensions and a three-dimensional, what Hobson calls the AIM state space, which has activation going from low to high, the source of inputs either internal, like memory, or external, like sensation and perception, and then modulation, whether the dominant mode of neural activity is characterized by a lot of aminergic activity or a lot of cholinergic activity. That's the AIM state space, and Hobson believes that, in principle, any state of consciousness can be located essentially as a point or as a space within this three-dimensional space. So, for example, when we're awake and alert and attentive, the way we are right now, we've got high levels of activation. The input source is external. You're paying attention to me or the Facebook update that you just got or whatever it is that you're doing. And this neuromodulatory balance is heavily weighted towards the involvement of aminergic neurons. So that gives you this characteristic pattern. When you're awake, you're up here. In stage NREM, stages 2, 3, 4 of the night sleep, there's a shift. There's a reduction of activation. There's more of a balance between internal and external. You still might be picking up something from the radio or from outside, but you're also having these thoughts pass through your head. And there's also a balance between the activity